So hello guys, I am here to explain Leetcode question number 3255. Find the power of k size subarrays 2. So this question appeared in bi-weekly contest 137. So we are here to discuss that question. Here we are given an array of integers num of length n and a positive integer k. Also we are defining the term power as the maximum element of that array if that array is increasing and all the elements are consecutive. Okay. For example, if we have array 1 2 3 4 5 5, so the power for this array will be 5 because the array is sorted and all the adjacent elements are consecutive in nature. Okay, whereas for any element that does not satisfy any of these rules, the power will be -1. For example, 3 4 3 4 3, the power will be -1 because despite being all the elements consecutive, this array is not sorted in increasing order. So the power will be -1, and same case goes for 1 2 3 5 6 7. This array is sorted in increasing order, but 3 and 5 elements, these are not consecutive elements, so the power will be -1. Now in the given array nums, we have to find the power of all the sub arrays of nums of size k. So if we take the example 1, in this array nums and k is 3, so the size of the sub array will be 3. For the first sub array 1 2 3, the elements are consecutive and are sorted in increasing order, so the power will be 3, maximum element. Same case goes for 2 3 4, the power will be 4, and then 3 4 3, this will give us power of -1. Same case goes for 4 3 2 and 3 2 5. Okay, so the output will be this. So now how can I solve this question? Okay, if I can see the constants, n is 10 to the power 5, the size of the nums is 10 to the power 5, which means that the worst time complexity we can go to is n log n. Okay, we can't go for n square, we can go max to max n log n here. So now how can I solve this question? Okay, so first intuition that comes to my mind is that for each element, what I can do is I can just find the longest chain of the elements which are like consecutive and are decreasing. Like for 4, the answer will be 4 because 4 3 2 1. Okay, for 5, the answer will be 1 because there is no elements. For 2, the answer will be 2. For 3, the answer will be 3. Okay, now then we will iterate from I is equal to 0 to I is equal to n minus 1 and check if any chain has length more than or equal to k. If so, we will just print out that element, because that element, if it satisfies all the conditions, that element will be the maximum element of that sub array. So I can just simply store that element. Okay, for example, let's just try to implement that here. Okay, this is our mini whiteboard, and let's try to do count is equal to for 1 that will be 1. Now 2 is 1 plus 1, so the count will be 2. For 3, count will be 3. For 4, count will be 4. But for 3 is not 4 plus 1, so the count will again become 1. Now for 2, the count will be again 1 because 2 is not 3 plus 1, the count will be 1. And for 5, the count will again be 1. Now let's iterate from I is equal to 0 to I is equal to n minus 1 for 1. But also let's start from I is equal to k minus 1. So let's start from here, such that we can have for all these sub arrays, we can just check the ending element for that sub array and just check if that element has a chain of more than or equal to k elements. That means that element can be a terminal element for that sub array. Like for 1 2 3 is, this sub array is valid because the chain for 3 is 3, which is more than or equal to k. Okay, fine. Now for 4, the chain is 4, which is more than or equal to k. So now why am I accepting more than k? Because we will then have this chain, right? But this chain also has this chain also, right? This 3 elements chain, so that is also an acceptable subarray. So let's just mark that also. Now for 3, the count is less than k, right? So I can't have that, so let's push -1. Same for 2, same for 5. So let's implement this as soon as possible. The time complexity will be linear because of n. Let's begin. I will also explain you while I write the code. This is the size of n of the array. Okay, now let's declare the vector count, initially having all the elements initialized with 0. Count for the first element will always be 1, because here for the case of 1, the longest chain can be only and only 1. So count 0 is 1. Now is starting from I is equal to 1 to n. If the current element, if the ith element is I minus 1th element plus 1, which means that I can just increment that count from the previous count. Like count for 2 will be count from 1 plus 1. So let's put the condition if nums of I is equal to nums of I minus 1 plus 1, the count for I will become count for I minus 1 plus 1. Great. But if this condition is not true, so the count will simply be 1. The longest chain that we can go to the left is only and only 1. Count 1 equals to 1. Okay, great. Now we have made our count array. Now let's just iterate through the elements from I is equal to k minus 1 to n. Now again I am explaining why, because we are checking for the terminal for the last element of each subarray of size k. So to get that, we can just iterate from I is equal to k minus 1 to I is equal to n minus 1. Now why that? Because all let's just write one subarray here. Okay, 2 3 4 3 2 5. This is our subarray. Now all the subarrays of size 3 that we can get from here are these: 1 2 3 4 and 5. Now you can see these are the last elements, which is 3, then 4, then 3, 2 and 5. So we are starting from 0 1 2. The indexing goes like 0 1 2. So 2 is k minus 1, so I can just start from k minus 1 till n minus 1. Let's write that. I is equal to k minus 1, I is less than n, plus plus. Now for each terminal, for each last element, if the chain is more than or equal to k, if count of I is more than or equal to k, also let's just declare one vector int answer, which is initialized to be the size 0. If count is more than or equal to k, I can just answer the push back, or else if not, answer dot push back minus 1, and then just simply return the vector answer. let's just dry run this code. Let's just check for any flaws. And this is okay. I is less than n. Okay, good. I is less than n. Count is greater than okay. Okay, I think everything looks good to me. Let's check for the test cases. That seems okay. Let's see. Why is it taking so long? I hope my net is okay. In the meantime, let's just dry run this code, or let's just check the sanity for this code. The code looks okay to me, but it's taking a bit too long to execute. That must be any issue from the internet or Leetcode itself. All we can do is wait. It's taking a bit too long. I don't know what is the issue here, but let's try. There's some network error. Okay, I don't know what is that network error, but let's just run again and hope. Yep, so all these test cases are accepted. Now let's just submit the code and see if the code gets accepted. Yeah, the code gets accepted. And let's just check the time complexity. The time complexity is linear. Okay, that is very great. The time complexity is linear because we are just running two loops here, and all the code inside the loop is constant time, so that's just linear time here also. So yeah, that was pretty much it. So see you with the next solution. Thank you.